Well, it looks like we're live again. Hello, everybody. Welcome to another AP Computer Science A live lesson. My name is Rob Schultz. I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerland. I teach in Hoover, Alabama at Hoover High School. We're so glad that you're with us today. Mr. Schultz and I are coming to you from Ohio and Alabama respectively, and we want to show you where our community is of learners. We've gone international in the last few days, and we haven't, of course, heard from everybody, and I've dropped one pin per state or per area so that it doesn't get too overcrowded, but it's really exciting to see all the different people that are joining us. I know you're at home, probably by yourself with your family, but I want you to have a sense of all the other students around the world who are also studying Computer Science A and taking this journey with all of us in spring of 2020. Today, we're going to be hearing from Mr. Schultz a lesson about the methods, particularly the methods on the Java Quick Reference related to ArrayList. And he's going to start us off today with a review of your Powerup homework to look at a specific free response problem. So that's going to be a treat. Mr. Schultz has been a reader for a long time, so take it away.
Okay, thank you very much. Well, so yesterday, part of your Powerup was to take a look at question number 2 from the 2018 exam. It's great having access to the links that were placed into the Powerup, but just on the off chance that you should ever want to look at one of the free response questions but not have access to those links, it's really easy to find them. Just do a Google search for AP Computer Science A exam. It will bring you to this page. I believe this is the first page that'll pop up, and then scroll down and you'll see the previous year's free response questions. So you'll see 2019, you see the free response questions, the scoring guidelines, the rubric, the canonical solution, the chief reader's report, all of the scoring statistics, and then sample responses from each question. And these are actual student responses with some commentary from the readers that were present that year as to why those specific students earned the points that they got. To see other questions, click on the link for practice free response questions, and you'll notice that it says free response questions from 2018 and earlier. I don't remember off the top of my head how far back they go, but it goes well back into the C++ era. So you'll even find questions out there from the free response questions from the exams that were written in C++. But when you click that, it'll bring up another link that looks like this. And for today, we're going to look at the free response questions for 2018. Okay, so let's jump right in. So question number 2, it says the question involves reasoning about pairs of words that are represented by the following word pair class. Now, a couple things I want you to notice before we dig in and start looking at solutions. When you read one of the questions, look for the specifics that are given. For example, in this case, they give us the outline of the word pair class. They give us a constructor, and then they give us 2 methods: get first, which returns the first string of this word pair object, and get second, which returns the second string of a word pair object. All of these are given as abstractions. We have no idea what the code actually is inside the constructor or the methods. We don't really need to know. All we need to know is that if I need to get the second string, I can call get second, and if I need the first string, I can call get first. It goes on to say that we're going to implement the constructor and another method for the following word pair list class. And notice that in word pair list, we have the declaration for an array list of word pair objects called all pairs, but that array list is not actually constructed. And they specifically tell us that it's initialized by the constructor that we are going to write. We have the header for a constructor, and we have the header for a second method, a method called numMatches that will return an int. And the purpose of numMatches will be described when we get to part B, okay? So as we look at part A, there's a lot of wording here. I'm not going to go through all of the wording, but I am going to point a couple things out. It says, write the constructor for the word pair list class. The constructor takes an array of strings, words, as a parameter and initializes the instance variable all pairs to an array list of word pair objects. I want you to make specific note of the wording and the font, because all of that is very purposeful. When the font is changed to, I think that's
Courier
New Roman. But when that font looks like that, thank you. I'm not a font guy. When the font is set in that specific way, that means that those specific variable names or array lists or strings, those have to be accounted for in the code that we write. We can't just write a generic array of strings. We literally have to reference an array of strings titled words. We have to write the constructor for the word pair list class. There's some detail here that describes how the constructor is going to work. It specifically says that, let's see, the word pair object consists of a word from an array paired with a word that appears later in the array. Essentially what that tells us is that when we get an array of strings, we have to create a list of word pairs where every single word in the string, every single word in the string array is paired with all of the words that follow it. So 1 gets paired with 2, 1 gets paired with 3, and then 2 gets paired with 3. When we look down at this example, the is going to get paired with more, the will get paired with the will get paired with merrier, and then more gets paired with the, more gets paired with merrier, and then the gets paired with merrier. Okay. The one last final thing I want to say about this specific free response question. One of the common errors that I see as a reader is that students will see examples and then think that they are writing the code specifically for those examples. So they will write very, very specific code that handles a string array called numwords that contains 1, 2, and 3, or a string array called phrase that contains the, more, the, and merrier. Keep in mind that these are just examples. We need to write our code so that it will work for any string array of any title with any number of words. Okay, these are just there for example purposes, right? When we get to the last week of this, when we get to the last week in April that we're going to be doing this, we're going to spend the entire week going in depth into free response question strategies and different things to watch for, and we'll do scoring. So we'll get into more depth as far as general strategies. But again, I just wanted to mention that for this specific question. So this is a 9-point question. Part A is worth 5 points, and to get the 5 points, we have to do the following 5 things. We have to create a new array list and assign to all pairs. We have to access all of the elements of words with no bounds errors. We have to construct a new word pair using distinct elements of words. We have to add all of the necessary pairs of elements from word array to all pairs. And when we exit the constructor, all pairs has to contain all of the necessary pairs and no unnecessary pairs. And there was also a 1-point question specific penalty in this one. We all know that a constructor cannot return a value. So there was a question specific penalty on this question that if you did all of this stuff correctly, or even if you didn't, if you got even one of these points correct, but then at the very bottom of your constructor, you put return true or return 0 or return 1 or return anything, it was an automatic 1-point deduction. So something to keep in mind, if we're writing constructors, we can't put a return statement at the bottom, okay? So this is what the chief reader posted, and you'll find this out at the link that Mrs. Westerland shared. This is what the chief reader posted as what's called the canonical solution. This is the benchmark solution that we used for this question. And what I'd like to do is kind of quickly walk through and point out where all 5 of the points were earned for this solution. Now, like I said, we could spend a lot of time talking about all the what ifs. We'll take care of that during our last week of April. For now, we're just going to kind of quickly walk through this specific solution, okay? So the first point, creates a new array list and assigns it to all pairs. Well, remember, all pairs was constructed in the class, but it wasn't actually, it was declared, but it wasn't actually constructed. So inside the constructor is where we actually create a new array list and we assign it to all pairs. Okay, we have to access all of the elements of words with no bounds errors. Well, we have words I and words j. We have nested for loops. I is going to go from 0 up to words.length -1. And we specifically need to go to -1 because j starts at I plus 1, so that we want to make sure we don't go out of bounds. So the way that our for loops are created and the fact that we use I and j to reference specific elements in words, we will access all of the elements of words with no bounds errors. Do we construct a new word pair using distinct elements of words? Yes, we create a new word pair object using 2 specific strings from the words array. And do we add all of the necessary pairs of elements from the word array to all pairs? We do. Now, in this case, we get exactly the pairs we need. Again, one of the common mistakes we saw in this question was to start J at 0, which means we would also get a lot of extra pairs of elements that we didn't need. And that would be okay for this point. As long as you get the necessary pairs, even if you throw in some unnecessary pairs, you're still going to get the point for this one. The place you would get kind of dinged for that would be this last point. It says on exit, all pairs contains all necessary pairs and no unnecessary pairs. So essentially, did we get exactly what we needed? No more, no less to get this point. And the answer would be yes. So that's where the 5 points from the canonical solution come from. As we look at part B says that we're going to write the word pair list method num matches. This method is going to return the number of word pair objects in our all pairs array list for which both strings match. And in this case, we have the red fox, the red. When we implement or we invoke the instructor, we're going to the constructor, we're going to end up with this array list of word pair objects in our all pairs array list. So when we run the method, we're going to end up with 2 num matches because there are 2 elements inside our array list where the first string matches the second string. So again, I just want to look at the points, look at the canonical solution, and then we're going to move on to the methods for today's lesson. Okay. So again, it was a 9-point question. Part A was worth 5 points, so part B is worth 4 points. To get the 4 points, we have to access all of the elements in all pairs with no bounds errors. We have to call get first or get second on an element from list of pairs. And at this point, I usually have some students in my own class when we've done this as an in-class example, kind of raise their hand and say, hey, where did it get these 2 methods from? Where was get first and get second? Because those aren't methods that we would normally be familiar with. We'll talk about that in just a second, okay? Do we compare the first and second components of a pair in the list? And do we count the number of matches of pair-like values? So those are the 4 things that we have to do to get the 4 remaining points. Again, here's the canonical solution from the chief reader. So walking through the points, the first thing I wanted to point out, I guess, before I walk through the points, refers back to this get first and get second. Remember in the problem definition, we were given the layout of the word pair class, and the 2 methods that are in there are get first and get second. So part of the requirement is that we use get first and get second on a word pair object so that we can figure out what the first string and the second string are. So for the students that were wondering where get first and get second came from, keep in mind that there was information that was given to us back in the description of the problem that we can apply later. Okay. So the first point, do we access all of the elements in all pairs with no bounds errors? Yes. In this case, we very effectively use a for each loop. So we're getting each word pair object pair from all pairs, and because we're using a for each, we're preventing the possibility of any bounds errors. So point 1 is good to go. Point 2, do we call get first or get second on an element from list of pairs? And notice the wording. We don't necessarily have to do both to get the point, this specific point. All we have to do is call one or the other, but in this case, we call both, okay? The third point, do we compare the first and second components of a pair in the list? We do. We have pair.getFirst, we have pair.getSecond, and we have a comparison in between. So we're comparing those 2 components of a pair. And then the last point, do we count the number of matches of pair-like values? We do. We iterate through our loop. If we find a matching pair, we increment our count. And again, the most common mistake that I remember seeing on this specific question was forgetting to either declare or initialize your variable that you're using as your counter. Even if you have the for loop, even if you have the if statement, even if you're incrementing a counter, if you don't declare your counter and set it equal to 0, excuse me, you are not going to get this point because we're not effectively counting the number of matches of pair-like values. Okay, so that is our free response question. That's question number 2 from 2018. I encourage you to go out and take a look at some of the student samples. Look and see what some of the other students that took this test actually did on that question. Look at the things they did correctly to earn points. Look at the things that maybe they might have made a mistake here or there to cost them points. But specifically, I want you to make note of the fact that this is not a binary all or nothing type of problem. It was very common to see 7 out of 9 points or 8 out of 9 points. and there are ways in here that you can get points by implementing certain parts of the problem or solving certain parts of the problem without having to get every single piece. Okay. Again, we'll talk more about free response questions in the coming weeks, and we'll dig really deep into free response questions during our last week. Okay, keep in mind at the end of each review session, we're going to provide info and resources to equip you to power up. This was last night's power up. Let's very quickly just review some strategies before we get into today's lesson. Okay, keep in mind that we're trying to keep things course focused and concept based. We are encouraging you to handwrite code when you can. That's our primary goal because we want you to have a lot of practice handwriting code. It's very easy to kind of rely on your IDE, okay? So we want to get in the habit of writing code from hand so we don't have any IDE to kind of help us or give us hints. And at this point, past AP exams, I know we've said that we really don't know what's going to be coming with this year's AP exam and the free response questions, but past AP exams have all been handwritten. So hopefully we'll know more about this year's AP exam. There are some announcements due to be made on April 3rd. But even if this exam ends up not being handwritten, being able to handwrite code is still a good skill to have. After you've handwritten your code, then we encourage you to go back and implement it, test it, make sure it runs. Mrs. Westerland has done a great job of keeping her own journal of notes. She's modeling good note-taking skills, and she's got a folder out in our shared area that in addition to the power-ups, she's also sharing her journal note images with you. So hopefully everyone is keeping good notes. If not, this would be a good time to start working on developing those note-taking skills. I assume a lot of you are seniors, you're going to be going on to college next year, and they're going to expect you to be able to take good, solid notes. And that's definitely a good skill to have. So take advantage of the opportunity of having some excellently modeled notes to work from. Okay, today's lesson. We are going to start getting into specifically the ArrayList methods that are on the in this CED. I almost said CDE, the CED. Specifically the ones that are in the AP subset. Now, I will say this, just like pretty much everything else we've done up to this point, you've probably already heard me refer to the fact that we're touching the tip of the iceberg, and my students will tell you I use that term a lot in my class. And this is another good example. We're looking at 5 specific methods, and that is the tip of the iceberg with ArrayList. There are a lot of other great methods out there that are very helpful, but we're going to focus on the ones that are part of the AP subset. In other words, the ones that you could be asked to deal with on the AP exam, okay? Some prior knowledge, instantiation of an array list, which Mrs. Westerland went through with you yesterday, and ArrayList traversal, which Mrs. Westerland also went through with you yesterday. Today, we're, like I said, specifically to get to the 5 methods. We're also going to talk about the fact that an array list dynamically manages its own size as elements are added and removed. And I know that was discussed yesterday as well, but we're going to add or at least kind of review that a little bit, okay? All right, so for our 2-minute prep, and I didn't think to add a little music clip behind mine like Mrs. Westerland did yesterday, so I'll work on that for next time. But I am using the Animals CSA class from yesterday. What I would like you to do in the next 2 minutes is I would like you to write the code necessary to do the following. I would like you to write the code to instantiate an array list that will contain Animals CSA objects. And then I'd like you to write the code that will let us traverse the array list and display the string that's returned by each object's toString method. Now, don't worry about putting in anything into the array list at this point. We'll do that in the next, in the coming slides. All we want to do is instantiate an array list and then write the code that will let us traverse it as we go. Okay, so take a couple minutes. Go ahead and start. Mrs. Westerland, since I forgot to add music, would you like to sing for us?
Oh, I'll pass. Thank you, Dan. They'll be sad because it would definitely not be as loud as yesterday's music, but it would be way worse than yesterday's music if I were to sing.
Oh, this might be a good time to mention. I forgot to mention yesterday, for me, this is Hawaiian shirt week because my school is on spring break this week. So this is my way of celebrating since I can't really leave my house right now. This is my way of celebrating my spring break. So my plan is to wear a different Hawaiian shirt every day this week as my celebration of spring break. This is as close to an exotic beach somewhere as I'm gonna get.
That's about true for all of us right now.
My problem is we've got 5 days this week and I've only got 4 Hawaiian shirts. So one of them is going to have to be recycled by Friday.
We'll let that pass.
Okay, we've got about 1 more minute to go. I think I hear JJ at the door. She's sniffing. My door's closed and she's sniffing, trying to get in.
She knows that she's going to be talked about today.
Yeah. Okay, let's go about 15 more seconds. Oh, JJ wasn't at the door. JJ.
She under your desk?
Yeah. I'll move the camera down so you can see her on the next one. Okay, let's take a look and see what we've got. Okay, so to implement an array list that will contain animal CSA objects, we can look at the first line of code at the top. We've got array list, and then in our greater than, less than brackets, we've got animal CSA. We're going to call it pets, and then it's going to equal a new implementation of array list animal CSA. So, so there is our array list, and we're going to talk more about that in a second. For the traversal, we're going to start at index position 0. We're going to continue as long as our index is less than the size of our array list. And we're simply going to say system.out.println pets.getIndex.toString. Okay. And I know the toString is kind of an extra add-on in there. It's just a habit that I'm in. I know some students include it, some teachers include it, some don't. I've just always been in the habit of putting it there. But if you just did pets.getIndex and did not include the toString, you're okay. All right. So what you need to know, here we go. So we've already talked about 2 of the 5 methods without really thinking about it because they were covered yesterday and we just covered them again in some of the things that we just did with our traversal. The first one is Int Size. And what Int Size does is it returns the number of elements in our list. So that becomes handy if we want to know how many elements we have for whatever given reason. Or if we're trying to traverse the array, we really have to know how many elements we need to traverse. So as you look down at the code I have for our traversal, actually, let me kind of describe what I did. The code that I'm going to be putting together that we're going to kind of build onto is going to be out in the shared folder with the other resources that you can look at. To make it easy for us to kind of look at things as we go, as things are added, this is going to be my Bob Ross moment, and I apologize for those that don't know who Bob Ross is, but I made this happy little status method that's going to live at the bottom of our class, okay? Like I said, if you don't know who Bob Ross is, that probably made no sense. But if you don't know Bob Ross, Google him. It would be worth your time. In any event, I made a status method that's going to take an array list of animal CSA objects. The first thing it's going to do is it's going to tell us the size of the array list. And then it's going to traverse the array list and show us each individual element that's in the list for us, okay? So at this point, if I were to put this code into my program and compile it, all it would do would say the size of the array list, colon 0 elements, because at this point we haven't put anything in, okay? The other thing I wanted to point out is that we've already really talked about the get method, and the get method is simply there to return the element that's at position index. So in this case, as we're traversing the array, we have a loop control variable called index. And every time I pass through the loop, we're going to get whatever value happens to be at the, or we're going to get whatever element happens to be at the current value of index. So right off the bat, we've got 2 of our 5 methods pretty much wrapped up and taken care of for us. Okay? So when you go out and look at the code, if we have time today, again, like yesterday, I think this might be another bell-to-bell lesson. But if we have time, I'll pull the code up so that I can show it to you and show you where the status method is at the bottom. Okay? So let's get to the first one. The first one is our add method. And I'm going to describe what the add method does. I've got some examples up here. The add method will automatically append the specified object to the end of the list. Now, I mentioned that the methods we're talking about are the tip of the iceberg with array lists. Several of the methods that are in the array list class are overloaded. And at this point, we've already covered overloaded methods. We know what that means. For those that weren't with us when we talked about that, really all that means is that I have multiple methods in the same class that have the same name, but they have a different parameter list, either different types or different numbers of parameters. And add is one of those methods. So for our first version, the plain old vanilla flavor of add, really all I do is I give it an object and it appends the object at the end of my list. It'll dynamically increase the size of my list by 1, and it returns a Boolean value. So there are 2 different ways I can use add. In this case, I have to give it an animal CSA object. So the first option would be to actually create an animal CSA object to instantiate a CSA object named temp animal. In this case, temp animal will be a new animal CSA object, Sunshine the dog, representing Shorecrest in Florida. And then once I've done that, now that temp animal is an actual animal CSA object, I can simply say pets.add temp animal. The other option, if I want to avoid having to create a specific instance of that object that I'm going to save, would be to simply say pets.add new animal CSA. And in this case, we'll do Spaz the cat, representing Great Mills in Maryland. So because I did Sunshine first, Sunshine was appended onto our empty list in position 0. And then we created an instance for Spaz the cat, and Spaz was appended onto the end of the list and now has position 1. If I were to add another object using the same method, let's say this time we want to add a new animal CSA object for Sababu the snake from Georgia Tech in Georgia. I just love that name, Sababu. Once I do that, it's going to append an object and an animal CSA object onto the end of our list for Sababu the snake from Georgia Tech, Georgia. Okay. So that's the first way that we can use add. The second option would be if I want to add something at a space other than the end of the list. So there's a second version where we have void add. I can provide a specific index position along with the object that I want to add. Now I'm going to break in at this point, and I'm going to share that I do get a common question from my students, and I have to be honest, I've never researched it, I've never looked, and I don't know, but a common question I get is, why does this one return a Boolean and this one returns a void? I don't have the answer to that question. I would love to say that I know everything about everything there is to know about Java, but I don't. So this is usually one of those things where, yeah, I don't know. I don't know why they designed it that way, but it might not be a bad idea for the student if they're really interested in figuring out why, to look it up and see what they find. And sometimes my students will do that. Sometimes they don't. They've never come back to me and told me what the actual answer is if they have, and I've never really been concerned about it enough to look it up. So if you are curious as to why one is Boolean and one's void, take a look, see if you can find an answer. And then let us know what to find out. Do a little research. So getting back to our add method, what the add method does. If I say I want to add a specific element at position 1, it's going to move all of the elements at position index, in this case 1, and higher to the right. So Sababu will move from position 2 to 3, Spaz will move from position 1 to 2, and we effectively leave an open spot for our new object. It then inserts the specified object at the given index position. So in this case, Nellie the dog, representing Roland Hall in Utah, will be inserted into position 1 or added in position 1. And then again, just like the other version of add, this version dynamically increases the size by 1. So keep in mind that array lists aren't like arrays where we have a set physical size. Array lists will dynamically increase their size every time we add something to it. Okay, those are our 2 add methods. The next one is our set method. Now, I can tell you based on my experience that my students typically think that add and get are really the only methods that we have, the only methods that we need. So I have to keep reminding them that there are others. If I want to replace something in a specific position, I don't have to remove it and then add something else into the spot. I can use set. We have a set method, and what the set method does, it takes an index position and an object, and it replaces. It doesn't add, it doesn't insert. It replaces the element at the given index position with the specified object. It does not change the size. I'm not adding anything. I'm not removing anything. I start with 4 elements. If I set something, I'm keeping 4 elements. But what it does do, so that we don't lose anything, and this is easy to forget too, it returns the element that was originally at the given index position. So if you look back to the previous slide, we had Nellie the dog representing Roland Hall in Utah. Well, if I come down and say I want to set position 1 to a new animal CSA object, Bo the dog representing Hoover from Alabama, it's going to replace Nellie with Bo, but I don't necessarily want to lose Nellie. And because Nellie is being returned, I can create a temporary variable, or again, you can call this whatever you would like. I can create a variable, an animal CSA variable, that will let me hold on to the reference of Nellie so that I don't lose where Nellie the dog is. So by going through and using pets.set and setting position 1 to Bo the dog representing Hoover from Alabama, Nellie being the element that was originally in that position gets assigned to temp, and that way we don't lose track of where Nellie is. Okay. Now, set comes in really handy if you have to swap objects. And I've already started kind of working ahead on the slides for Friday where we're going to be talking about doing some sorting. There's going to come a time where we need to swap things in an array list. So here's how this works. I need to try and get Bo and Spaz to swap places. And to do that, I have to kind of juggle things a little bit. Working with array lists really makes that kind of easy. What I'm going to do is I'm going to say that I want to get the element that's at position 2, in other words, Spaz the cat, and I want to set position 1 to that element. So remember, that's going to go through and it's going to replace whatever is currently at position 1 with what's at position 2. Spaz the cat will replace Bo the dog. I don't want to lose track of Bo the dog because I still have to get Bo the dog back over to position 2. So I'm going to temporarily assign Bo the dog to temp. And once I've got Spaz moved to position 1 and Bo moved down to temp, then the next thing I can do is I can say, okay, well, now let's take whatever's in temp and assign it to position 2. So we end up with this. So Spaz moves to position 1, Bo moves down to temp, and then we take temp and assign it back to position 2. So there's our swap. So keep that in mind. If you're taking notes, try to put a star beside that because we'll come back and refer to that on Friday when we're talking about sorting algorithms and how we might swap two elements in an array and, well, in an array list, okay? The last one we need to talk about is our remove method. And I, again, want to point out the difference between an array list and an array. Okay, when I remove something from an array list, I'm not just setting its reference to null. I'm not just setting it to 0. I'm physically removing it from the array list and I'm sliding everything down to fill the position. So if I say I want to remove Bo the dog from our array list, sorry, Bo, if I say I want to remove Bo the dog from our array list, the first thing that happens is it removes that element at the given index position. It moves all of the elements at index position +1 and higher to the left. Sorry, I backed up here. For my example, we had Spaz in position 1. We're removing Spaz. So I'm removing Spaz. Bo the dog is going to move from position 2, and Sababu the snake is going to move down from position 3. We dynamically decrease the size by 1, but I don't want to lose track of the element that was originally there, Spaz the cat. So again, just like set, remove will also return whatever element happened to originally be at that position. So in this case, because we removed the animal CSA object that was at position 1, Spaz the cat, Spaz now gets assigned down to our temp variable. Bo moves down from position 2 to position 1, and Sababu moves down to take Bo's place. Okay, so that's how our remove works. Keep in mind, again, and this is another one that traditionally my students find it easy to forget. Set and remove both return whatever was originally at that spot. It's not instantly gone. If we replace something, we still have access to what was originally there. If we remove something, we can keep track of what was originally there. Okay, so those are our 5 elements. Here is our check for understanding question. And this is one of my favorite types of questions to ask my students, because if you are a Star Wars fan, you will get this reference. In my class, I would refer to this as an Akbar question. Now, for those that are fans of Star Wars, you know what that means. If you are not a fan of Star Wars, Akbar, and I'm not a ginormous Star Wars fan, I like the movies. Akbar, I believe, was a general in some of the movies and an admiral in some of the movies, but his character is known for saying, "It's a trap." So this is one of those questions that, as an Akbar question, Be careful, it's a trap, okay? What I would like you to do is, given the array list of our dogs, it's an array list of strings, I'd like you to remove all of the elements containing the string JJ. And I'm gonna give you, let's say 3 minutes. I'll give you 3 minutes to work on this one. See if you can go through, traverse the array, and remove all of the elements containing the string JJ. Go. And JJ perked up. I know we're supposed to keep the camera on us, but I'm gonna move it for just a second.
You're saying her name so much.
I know.
She's asleep.
JJ.
Oh, there you are.
There's JJ.
Hey, JJ.
Now she's laying there going, what, did you wake me up? Okay, so we are just at the 1 minute mark. You've got about 2 more minutes to go. And then we'll walk through it together. So because I'm on spring break, I was going to try and do, like, I've got this beach background that I use for one of my other classes. We do green screen programming, and then we take pictures in the green screen and put ourselves in all these cool places. So I've got this really nice beach background that I was going to use for my temporary virtual background. But because my gray hair is close to the same color as the floor behind me, my hair ends up becoming part of the background. So I didn't.
Plus, you'd make us feel bad. Because, you know,
What?
we're not at the
yeah.
beach. You'd make us feel bad.
Yeah. Well, believe me, I'm not. There aren't really any good beaches in Ohio.
It's raining here today and blowy and kind of chilly. It was beautiful yesterday.
Yeah.
I hope it's beautiful where all of you are and not dreary.
We've got about 30 seconds to go. Yeah, it's kind of a cold, dreary day here. It's been in the 60s. We even hit 70 one day last week, and it's back down into the 40s this week in Belgrade. Okay, let's take a look at what we've got. Now, at first glance, this code looks like it's going to do everything we want it to do. We're going to traverse our array list of dogs. We're going to look, and each time we find a dog that returns a string that is equal to JJ, we're going to remove it. But the problem with this code is that if you run it with this array list, this is the result. We're going to leave one occurrence of JJ behind. And I'm going to explain why. I want to step through it quick. I know we're going to be pushing time a little bit. We've got about 7 minutes to go. So I'm going to do this kind of quickly because I think it's a good habit to get into to trace your code and test it. And there's a logic error with this one that's going to cause a problem because of the behavior of the remove method, the array lists, right? As we work our way through this, when we set our index equal to 0, we look at bow. Bow is not equal to JJ, so we skip it. We come to the top of the for loop, and we set our index to 1. In this case, we get the value at position 1, which does equal JJ, so we remove it. And bow slides down. Everything above JJ that was in position 1 slides down to fill the spot. We now have 7 elements instead of 8. We come to the top of our for loop, and we set index position to 2. We get the value at position 2, which is bow, which does not equal JJ, so we skip it. And we come back to the top of our for loop again. We set our index to 3. In this case, the object at position 3 does equal JJ, so we remove it. And everything slides down from position 4, 5, and 6 into 3, 4, and 5. But notice our index is still position 3, and we haven't come to the top of the for loop yet. So now as I come to the top of the for loop, we're going to increment our loop control variable to 4, which means now we're looking at the value in position 4 and it equals JJ. So we'll remove that one. Bo will slide down to take JJ's spot. We'll come up and we'll increment our loop control variable to 5, which is now not less than our size because our size is equal to 5 at this point. The size has dynamically changed as we've moved. So I jump out of the for loop and we've left one occurrence of JJ behind. Okay, so here's the trick to this. Because everything in an array list slides down when you remove something, we have to accommodate that in our for loop, which means we have to add an index minus minus anytime we remove something. So that if I remove something, I'm going to back up one position because I know when I go forward one position, and that way I can have an opportunity to look at whatever was moved into that spot. So that's the trick to this question. And like I said, that one's a common one to see. I put it on my own exam. I put it on tests. It's not totally unheard of that it would show up on an AP exam and maybe a multiple choice or as a part of a free response question. It's a good question to have because it really makes sure students understand how the remove method works and what the behavior is. Okay, we're down to 5 minutes. We need to move forward. So I'm going to kick off our debrief. I'm not going to rehash all of these slides, but really this is everything we've talked about today. Size, get, add, both flavors of add. We have our set method, our remove method, and what each one of them does. So as we get into our next power up, Mrs. Westerland, would you like to take this one over or do you want me to keep cruising along? Okay, I'll let you know.
So, and I'm going to quit talking before you hear the next. So resources are in the shared drive for you. And this would be a great thing for you to work through tonight is add some more fake animals or real animals to your array. We also want you tonight to look at free response question 2017 number 1. This denotes part A, but I think Mr. Schultz is going to go through both parts. It's another array list question from a recent year. So it'll be, very relevant for us to look at that. And then the next slide, I think, is where we're going to share some pictures. Yeah, and Mr. Emery has written us a song. So I'm going to be quiet and let you hear Mr. Emery from Cedar Park High School in Texas.
Can you hear it?
Yeah.
Okay, tell me if it's too loud. I can't hear anything on my end.
It's good.
30 seconds can be a lot of time, filling in with nonsense and not a single rhyme. So now the students in APCSA should study hard to take a test someday. The time to finish this song is coming soon. Be sure to power up and do your homework to CSA.
Love that. It's an original Mark Emery special from Austin, Texas. So these are some other students who've shared puns and pictures with us. So we love hearing from you. And let's see, the next slide I think is going to share if you have a technology issue. No, this is how to turn in a picture to us or a song if you code something. bit.ly/my2bits.
Oops, sorry.
The next slide, no, you're good. You can go down one more slide. This is the device and internet access. Go to cb.org/tech if you need assistance with technology. And we thank you for joining us today for exam review. Come back tomorrow. We're going to kick off recursion. I'm going to be teaching about some of the common recursive programs that a lot of people think of when they think about recursion. So join us tomorrow.
And
Y'all have a
definitely
good
keep your pictures of your pets coming. And thanks for listening today. And yeah, we'll see you tomorrow.
Bye.
Goodbye, everybody.